We've spent some time this unit talking about different types of radical functions, so now I want to look solely at the square root function and its domain. So we've looked at domain before. Remember, your domain is your possible x values. And when we looked at domain with quadratic functions, we talked about how the domain could be all real numbers. We never had to worry about what we call restrictions. You could square anything, you could multiply by anything, and you could add or subtract anything, which are the operations that occur with quadratic equations. With radicals, however, we have to be a little bit more careful because, as you've seen in the past when we studied complex numbers and during quadratic equations, negatives can appear under radicals, giving us those complex or imaginary numbers. So if I look at this generic function here, y equals the radical ax minus h plus k, I'm going to ask myself, what has to be true of ax minus h? What has to be true of what's underneath my radical in order to get real numbers? Well, in order to get real numbers, doesn't ax minus h have to be positive? So I have to ask myself, how can I take ax minus h must be positive and turn it into something solvable, something in mathematical form? Well, I know that if it's positive, it has to be greater than or equal to 0. So in general, whenever I'm talking about domains of square root functions, the expression under the radical, in this case ax minus h, must be greater than or equal to 0. And again, that is the expression under the radical. Notice I didn't say anything about the k, because again, it doesn't matter what gets added or subtracted. We can add or subtract any number. So let's go ahead and look at some more concrete examples with numbers put in. So I want to state the domain of each of these following functions. So on the first one, I'm given the radical of 4x minus 1. Well, 4x minus 1 is the quantity that's underneath the radical. So in order to get a real answer, I need 4x minus 1 to not be negative. So in other words, 4x minus 1 has to be greater than or equal to 0. Well, this is just a linear inequality. You've seen these before. This is easy for me to solve. I'm going to go ahead and add 1 and divide by 4. So in order to get an answer of real numbers, I have to have all my x values be greater than or equal to 1/4. If they are not, this expression right here will be negative, giving me imaginary numbers. Let's look also at example B. I'm going to do the same thing. I'm going to acknowledge the fact that the 12 is fine. The 12 can be disregarded when talking about the domain, but the 3x plus 6, that has to be greater than or equal to 0, because if it's not, I will get a negative under a radical, which will give me imaginary numbers. So I'll start by subtracting the 6 and get 3x is greater than or equal to negative 6. I do not have to flip my sign when subtracting or adding negatives, but I do remember, and I don't have any examples like this, but I do if I ever multiply or divide both sides of an inequality by a negative, please don't forget to flip your sign. It doesn't matter what the context is you're working in. From here, I can then divide by 3, giving me x is greater than or equal to negative 2. So you may say, wait a second, you said something about negatives. Yes, I did. I said the expression under the radical, that entire expression can't be negative. It doesn't mean that x can't be negative, because if x is negative 2, it's going to make this 0, and I can take the square root of 0. If x were negative 1, it would make this the square root of 3, and even though I don't know what that is, I know it's a real number. It's some crazy irrational number that goes on forever. So it's okay if in my restrictions I have negatives, as long as I solved what was under the radical to get those restrictions. Looking at one final example, I have a lot going on here. I have a number being multiplied out front. I have a divisor here of 8. I have a quadratic piece right here. But the only thing that I am going to be concerned about when I am stating the domain is what's under my radical. So I'm going to ignore everything else and isolate that 2x plus 5. And I'm going to say that that 2x plus 5 has to be greater than or equal to 0. Solving that, I subtract 5, giving me 2x is greater than or equal to negative 5. I divide by 2, and I get an answer of x has to be greater than or equal to negative 5 over 2. It can be any value as long as it's bigger than or equal to negative 5 over 2. Because again, anything less than that will give me a negative under my radical, which will give me an imaginary number. That is how you will find the domains of a square root function.